Welcome to the FHIR Sync Agent Mappings Tech Talk. My name is FHIR Yarapotina, and I'm a solution architect in Microsoft Dynamics Fast Track team. I'll be presenting this session today. This Tech Talk is intended for solution architects, technical and functional consultants, and the Cloud for Healthcare implementation teams from both customers and partners. FHIR Sync Agent Mappings Agenda. This Tech Talk highlights the FHIR Sync Agent data flow to show where maps fit in, cover the FHIR concepts, and Dataverse tools where mapping is configured. Finally, explains the mapping types and syntax with examples. So the agenda is split into 4 parts. In the first part, we talk about FHIR Sync Agent data flow. That is the data flow walkthrough from Azure API for FHIR to Dataverse and from Dataverse to Azure API for FHIR. In the second part, we cover about FHIR concepts that are needed to understand the mappings. We cover resources, profiles, and implementation guides. In the third part, we cover Cloud for Healthcare data model and tools where you can configure the mappings. In the final and fourth part, we go in detail about Dataverse mappings. We talk about mapping types, the JSON object syntax that is used in the mapping, cover a little bit about JSON path syntax, and finally explain mapping types with some examples. FHIR Sync Agent overview and data flow. Before going into the data flow, let's understand what is FHIR Sync Agent and why we need it. FHIR Sync Agent is a data synchronization solution between two data service platforms, that is Azure API for FHIR and Microsoft Cloud for Healthcare, which is based off Dataverse. And why we need FHIR Sync Agent? Essentially, Azure API for FHIR and Dataverse are two different services from Microsoft. Azure API for FHIR uses flexible data structure like JSON, XML, or RDF, Resource Description Framework representation. And Dataverse uses relational data tables and column. FHIR Sync Agent is created to synchronize data between these two services securely and seamlessly. If you look at the architecture, FHIR Sync Agent sits between Azure API for FHIR and Dataverse. FHIR Sync Agent consists of some Azure components, that is Azure functions with app service plan, application insights, storage, service bus queues, and topics. It reads the configuration stored in Azure Key Vault and processes the messages received from FHIR in the FHIR updates queue and from Dataverse in Dataverse updates queue. Essentially, Sync Agent is responsible for processing and transformation of the changes from both directions, that is from Azure API for FHIR to Dataverse and from Dataverse to Azure API for FHIR. Before going to the data flow walkthrough, we wanted to highlight a few things with this reference architecture. If you look in this reference architecture, you will notice at the center of the diagram, FHIR Sync Agent does not interact with the EMR directly. That is, it doesn't read data from an EMR system nor write to the EMR system directly. Instead, Azure API for FHIR with the help of FHIR Gateway or proxy is responsible for this. Any changes coming from EMR will be routed to the FHIR proxy, to FHIR, and eventually to Dataverse. Same happens when a change from Dataverse comes through. FHIR proxy is responsible for eventing, and Sync Agent is responsible for transformation and processing changes. FHIR Sync Agent data flow from FHIR to Dataverse. When a change is made to a FHIR resource in the EMR, the FHIR bundle is posted to the proxy. The FHIR proxy sends this change to Azure API for FHIR and gets the response back. In the second step, it verifies if this change needs to be propagated to Dataverse. This verification is done by proxy by checking if the resource is found in SA-FHIR map resources configuration setting on the keyword. If there is, if the resource is not found in this configuration, it will ignore. If the setting is found, the proxy would send the message to the FHIR updates queue. And the FHIR Sync Agent is listening to the queue, and when there is a new message, it will query the Azure API for FHIR to get the bundle. This is because when a message is received to the FHIR updates queue, it does not contain all the information. This is to avoid persisting PHI information PHI information on the service bus. Okay. Next, Sync Agent will verify if the Dataverse has the maps for that resource, and if it has the map, it checks whether there is an attribute that is mapped to a Dataverse field. Once the entity and the attributes maps are found, it translates and updates the respective field. So this completes the entire flow. For example, in this case, on the EMR side, the patient resource name has changed. That has been sent to the FHIR proxy, and the FHIR proxy has updated the Azure API for FHIR. Essentially, it updates that text that has changed and also increases the version on the Azure API for FHIR. Once that change gets back to the FHIR proxy, it verified if this needs to be sent to the FHIR updates queue or not. Because this is configured in the FHIR map resources, it sent the message to FHIR updates. And FHIR Sync Agent, which is listening to the FHIR updates queue, retrieved the needed information from Azure API for FHIR and transformed into the Dataverse. Before transforming, what it did was it checked if that the resource type is mapped in Dataverse, and if the map exists, it checks the fields that are mapped, and based on that, it updated the field on the patient entity in Dataverse, thus completing the flow from FHIR to Dataverse. FHIR Sync Agent data flow from Dataverse to FHIR. This flow depicts on how the Dataverse change propagates to FHIR. When a change is made on a Dataverse table for a field that has the attribute mapping defined and for the entity enabled for the sync, that change would be converted to a JSON payload based on the mapping defined, and that JSON message would be posted to the CDS updates queue. And the sync agent, listening to the CDS update queue, would retrieve the needed values for that FHIR resource and post that to the Azure API for FHIR, thus completing the flow. In this example, on the patient record, the mobile number has changed. Based on the mapping defined on the entity and the attribute map, that gets converted into a JSON payload. Please note that this message does not contain any PHI information when it goes to the CDS updates queue. So Azure, so the FHIR Sync Agent, whenever it receives, it sees that messages, it goes back to the Dataverse API and gets all the needed information to process that changed values to the Azure API for FHIR and sends it to the Azure API for FHIR, and thus completing the flow from Dataverse to FHIR. FHIR concepts. This section covers the FHIR concepts that are essential when defining the maps. FHIR, Fast Healthcare Interoperability Resources, FHIR, pronounced FHIR. It's a standard that defines how healthcare information can be exchanged between different computer systems, regardless of how it is stored in those systems. It allows healthcare information, including clinical and administrative data, to be available securely to those who have a need to access it and to those who have the right to do so, for the benefit of a patient receiving care. FHIR is the standard describing data formats and elements known as resources, and an API for exchanging electronic health records. One of its goals is to facilitate interoperability between legacy healthcare systems to make it easy to provide healthcare information to healthcare providers and individuals on a wide variety of devices from computers to tablets to cell phones, and also to allow third-party application developers to provide medical applications which can be easily integrated into existing systems. FHIR provides an alternative to document-centric approaches by directly exposing discrete data elements as services. For example, basic elements of healthcare like patients, admissions, diagnostic reports, and medications can each be retrieved and manipulated via their own resource URL. For the sync agent mappings, you need to understand the following FHIR concepts at minimum: resources, resource bundles, profiles, and implementation guides. A FHIR resource is the basic building block of FHIR. A FHIR resource is a discrete data concept such as a patient, document, medication, family history, health procedure, list of allergies, etc. A FHIR resource is literally any piece of data you can collect across the internet because it has a physical location that can be located via a URL address submitted in a browser. Several resources can be grouped together to create a bundle that is called a resource bundle. FHIR specification is broad with a lot of resources, and each attribute has multiple resources, and the same thing can be represented in multiple ways. So, need to constrain the specs to fit needs. That's where profiles comes into play. Profiles are nothing but extensions and constraints to limit the FHIR specification. A FHIR profile specifies acceptable codes, extensions, restrictions, and data types, and more. Implementation guides. Profiles are collected into implementation guides that describe national standard or complete use cases. Implementers use IGs to create actual APIs. Applications often state what IGs they support. Implementation guides also include associated documentation to clarify usage. Multiple implementation guides are available to handle different tasks such as constraints, customized operations, and management of bulk data, transfer of data. Some example IGs are US Core and International Patient Summary Implementation Guide. The important point is in FHIR Sync Agent, all the maps that comes out of the box are based on US Core Implementation Guide. Resource features. All resources have the following features in common: URL, where the resource is located and defined; common metadata, including resource type, ID, and a human-readable XHTML summary; an extensibility framework to support evolving methods in healthcare; and a set of defined data elements different for each type of resource. For example, in a patient resource, MRN, name, date of birth are standard elements that are required. Cloud for Healthcare Data Model and Tools. Cloud for Healthcare Data Model. The healthcare data model for Dynamics 365 is based on the Fast Healthcare Interoperability Resource, FHIR Standards Framework, Release 4, commonly referred as R4. The healthcare data model is already included in Microsoft Cloud for Healthcare solutions. It is also available as a standalone option for partners and Dataverse customers in the Microsoft Cloud Solution Center. The FHIR-based model makes implementation for healthcare customers easier, quicker, and more secure. Due to the many advantages FHIR offers, FHIR is widely used around the world and the implementation community is growing quickly. To learn about the FHIR standard framework, visit http://hl7.org/FHIR. Healthcare data landscape. Before we go into the mappings, it is important to understand the healthcare data. This helps to identify the entities that need to be synced between FHIR to Dataverse or vice versa. At the core of the healthcare data model, we have patient and physician information. It represents the patient record. These records need to be acted upon and exist within Dynamics or Dataverse. Data updates should flow back to FHIR or EMR. Non-clinical data. Non-clinical data is accrued through interactions with the patients. Typically, it would occur in the system of engagement, which is Dynamics or Dataverse. This data never goes to FHIR or EMR. For example, marketing, customer journeys, phone calls, cases, charts would fall into this category. And we have managed clinical data. Clinical data that the Dynamics participates in the creation or update of. Care teams, care plans, appointment scheduling are all examples of this data. This data need to exist in Dynamics. Data updates should flow back to FHIR or EMR. Finally, we have referenced clinical data. Clinical data that needs to be viewed in Dynamics or Dataverse. This data typically has a high number of transactions. This data doesn't need to exist in Dynamics or Dataverse. Example, medications, observations, encounters, etc. Depending on the use case in your implementation, it is important to identify the entities where the data need to be synced between FHIR to Dataverse and enable only those entities for the synchronization. Cloud for Healthcare Tools. Sync Admin for FHIR. This is a model-driven app that gets installed with Cloud for Healthcare solutions. This app will help to configure integration settings needed for the sync agent, manage entity and attribute maps, and also provides the sync agent logs. Entity maps. Entity maps associate FHIR resources to Dataverse tables. By default, all the entity maps that ship with Cloud for Healthcare are disabled. To sync an entity with a FHIR resource, that respective map must be enabled. You can also create new map or disable existing map. Attribute maps. Attribute maps associate FHIR elements to the Dataverse columns. These attribute maps are enabled by default, but these won't affect the synchronization until the parent entity maps are enabled. You can create, modify, or delete the existing attribute maps. Logs. Sync admin for FHIR logs its own actions and summarizes the sync agent actions. The logs doesn't contain EMR data. Each entry in the log has a description and it shows what sync agent tried to do and the result. Application configuration section has Azure FHIR resources, which displays all the FHIR resources under this section. Integration settings. Integration settings area gives you access to Dataverse environment variables that define and control the integration of Azure FHIR and Dataverse. Someone must set these variables to initialize sync admin for FHIR or make adjustments if something in your Microsoft Cloud for Healthcare environment changes. Data routes. The tables that support virtual health data tables are configured to route to Dataverse by default. In case if you need to switch it to the virtual tables, the data, you can use these data routes to configure accordingly. Cloud for Healthcare Tools. Dataverse maps. By default, with Cloud for Healthcare solutions, there are some out-of-the-box entity apps which includes needed attribute maps and FHIR element maps. These default built-in maps are based on US Core Implementation Guide. There are about 22 entity maps with 360 attribute maps currently. These maps helps you to get started quickly. These maps are disabled by default and you need to enable the maps for the entities that you need to sync to FHIR. To enable the maps, open the FHIR Sync Agent administration, navigate to the entity maps and enable for the entities you would like to sync. The Sync Agent admin app helps you to view the entity and attribute maps, enable or disable the maps, and also edit these maps. Sync admin for FHIR entity maps. Before going further, it is important to understand the purpose of each field that is available on the entity map form. First, we have a disable flag. It specifies whether the entity map is enabled or disabled for that entity. In this case, on the patient, and if the patient entity map is enabled or not. Second one is enable write back to FHIR. That field specifies whether Dataverse will identify changes on the record and trigger the write back of the FHIR data by posting a message to the service bus. Third field, entity name, is the name of the Dataverse table for which entity map is enabled for. Azure FHIR resource is the FHIR resource mapped to the Dataverse entity table. The supported messages field is nothing but the Dataverse message that are supported to trigger the write back to FHIR. Finally, expand. It's used to determine whether this entity map is for a root FHIR resource or one of the nested arrays which are represented as an entity in Dataverse. Sync admin for FHIR attributes maps. Let's take a look at the fields that are available on the attribute map form. First, we have a disabled flag. It specifies whether the attribute map is enabled or disabled. Next, the FHIR required attribute, which specifies whether the field is required or not when sending the data back to FHIR. Then the Dataverse attribute name is nothing but the Dataverse field name. And action type, the transformation defines the transformation action that will be performed. We are going to cover about the type of actions that are available when we go into the mappings section. The next element is the FHIR element map. This is where you would define the mapping needed for that attribute. Mapping definition to read the element from FHIR JSON also contains the mapping definition to produce the FHIR JSON for the Dataverse attribute. Then the use FHIR element type it is used internally. By default, it's defaulted to string. Used in record matching flag. This is a flag to indicate whether the current Dataverse field should be used to match the existing records and the expand action. This field is only important for attribute maps on an expand, where expand map is set to true. Finally, we have FHIR attribute metadata, reference to the extended FHIR attribute data. No reason to change this. So far, we have covered FHIR Sync Agent data flow, the FHIR concepts that you need to understand before you do the mappings, and also we covered about the Dataverse tools that are available to do the mappings, and also went in detail about each field that is available on the entity and attribute maps. In summary, if you have a change coming from EMR, you would get a JSON FHIR bundle to Azure API for FHIR, and the sync agent sitting in between Azure API for FHIR and Dataverse would read that entity map from the Dataverse and do the transformation needed to sync between Azure API for FHIR to Dataverse, and again from Dataverse to vice versa. So in short, FHIR Sync Agent is responsible for that transformation of data from Azure API for FHIR to Dataverse and back from Dataverse to Azure API for FHIR. So the key part of this Sync Agent is to define these maps correctly on the Dataverse side. So in the next section, we cover details about the Dataverse mappings. Dataverse mappings. Dataverse mappings, mapping types or action types. The mappings happen at the attribute level. So it is important to define the appropriate mapping type for the map that you are defining on the Sync Agent admin app. Copy data. This is used to copy the value as is from FHIR to Dataverse and vice versa. When the Dataverse data type is string, datetime, decimal, or integer, you can choose this copy data action type. Mapped value. Used to map fields from FHIR to corresponding Dataverse data fields. For example, data fields in FHIR use string representation, that is male or female for gender. And the corresponding Dataverse field use different values, that is integer 1 for male and 2 for female. So when you have this data type of pick list or Boolean data types in Dataverse, you can select the map value action type. Set default value. This is used to set contact type attribute. Since the same entity, contact is used to store patient and practitioner, a contact type attribute is used to differentiate these two FHIR users with integer values. And this mapping is not used anywhere else. Foreign key reference. Used to set the foreign key reference. Both FHIR and Dataverse data refers to the data in other resource types or entities using the data ID or primary key. For example, general practitioner in patient and contact. In FHIR, such reference is presented in the form of a resource type and resource ID separated by the /. In Dataverse, the foreign key reference is represented by a GUID value. Lookup codable concept. Similar to foreign key reference, the difference is these values are not primary keys. For example, in Dataverse, device type use predefined values that exist in a different entity called codable concept. In FHIR, this is defined as codable concept and their value vary by resource type. In addition to these 5 action types, we also added expansion maps. Expansion maps in Azure FHIR Sync Agent lets admin map complex JSON attribute to multiple related Dataverse attributes. With expansion maps, you can specify parent link attribute to determine the relationship between parent and child records. Mapping JSON object schema. Mappings happen at the attribute level. So in this example, we have an attribute map, that is a patient attribute on a client's entity mapped to a FHIR resource. To define the map, we have to create this FHIR element map. And this map follows this syntax JSON object schema notation described here. Yes represents a valid JSON path expression. It is used to select an existing JSON property of the FHIR resource to extract or set values from or to Dataverse. C JSON property field to use to insert or create JSON properties. This creates a FHIR bundle field when it doesn't exist in FHIR. P is the parent object of the entry to create. A represents the array of parameters to use when creating C. JSON path syntax. FHIR element maps are defined at the attribute level, and we talked about the object notation used in the previous slide. In the mappings, we use JSON path expressions to read from FHIR JSON bundle and set the corresponding attribute in Dataverse. Similarly, these JSON path expressions also help to populate the JSON object when sending data from Dataverse to FHIR. So the JSON path expression is an expression language to query or filter JSON data. A JSON path expression specifies a path to an element or a set of elements in a JSON structure. The JSON path expressions, including property names and values, are case sensitive. It is important to have some knowledge on the JSON path expressions. Some of the commonly used JSON path notations are shown below. Mapping examples. In the next few slides, we'll go through a few mappings with examples. This example shows how the family name on FHIR JSON bundle is mapped to the Dynamics 365 patient last name field. On the left-hand side here, we have a patient FHIR bundle, JSON snippet, and on the right side shows how the attribute mapping is defined on the FHIR element map field in Dataverse attribute map. So this would get a patient last name from FHIR to send to Dataverse, or update the last name attribute value from Dataverse to the family element in FHIR. This type of filtering is only possible on array types. If you look at it, dollar represents the root object and dot represents the child operator. So it's getting the child property called name, and then filtering the official name element and getting the family name from that JSON bundle. Again, to reiterate, these expressions are case sensitive. You can use any of the validation tools that are available for JSON path expression validation. Mapping example for an existing or non-existing fields. The following example would get or update the city field of address if it exists. If this was an update from Dataverse and address 0 didn't exist in FHIR, it would create an address parent and set the city value from Dataverse. It would also create placeholders or default values for other attributes from Dataverse that might be missing in FHIR. The JSON expression defined in the S section, in this case, $.address0.city would get the city value from FHIR resource bundle. The S section of the map is used to select the value when writing from FHIR to Dataverse and to create or update a node when writing from Dataverse to FHIR. The C section of the map gives flexibility on how to decorate a nested node when it is being created in FHIR for the first time. For the string values, the value set is the literal string defined in the attribute array unless it is one of the special character sequences. There are 3 special character sequences that we use in maps. % is used to copy the value of the Dataverse attribute at runtime. $% is to copy the type of the FHIR reference resources at runtime. For example, it is used as a placeholder for FHIR resource type and replaced with the actual value at runtime. 3% is to copy the type and resource ID of the FHIR reference resource. Mapping examples. Creating new nodes with this. Suppose we have 2 attribute maps defined for 2 different attributes on an entity. Then it would translate into a FHIR bundle as shown here. For example, in this case, we have a map for the first name and also for the last name. When an update is going from Dataverse to FHIR, that would translate into this patient FHIR bundle. Mapping example, creating new nodes with C. In this example, we have 2 attribute maps on an entity. And in the first attribute map, in the array, we use %sign in the create section. And for the second element, we use the X value. However, in the second map, for the first element, we used a literal value of X and the percentage character for the second element. So when an update comes from Dataverse to FHIR, the name node is created as below. So the use official element is the same from the attribute array. Family name as a literal string of X from both maps, and inside the given array, you get percentage, that is the Dataverse attribute value that gets replaced at runtime, and then the percentage, the Dataverse attribute value for the second element at the runtime, and resulting with a given name of this one highlighted here. Mapping example for a pick list. The following example shows a pick list mapping. On the left-hand side, we have a snippet showing the patient FHIR bundle Marshall status node. On the right-hand side, we have the mapping defined for the Marshall status Dataverse attribute on the patient entity. The S and C sections follow the same patterns that we discussed before. On this map, we have an additional element U. This is used in updating associated elements such as display and text, which is represented in the U element of this mapping. Mapping example, foreign key reference mapping pattern. This example shows how to map a foreign key reference. On the left-hand side, we have a code snippet from a patient FHIR bundle showing the managing organization. On the right-hand side, we have a corresponding Dataverse attribute map defined for that element in Dataverse. The S section would get the lookup value by using managing organization reference value. And for the C section, when the Dataverse updates are going to the FHIR and the FHIR doesn't contain this managing organization node, the C section creates that JSON node needed. With the P defining as a managing organization, with the attribute array reference with the triple percentages, which gets the type and resource ID of the FHIR reference resource, and type, which copies the type of the FHIR reference resource, in this case, the patient. Mapping example for a codable concept. Codable concept is made up of a text, a code, and a type. FHIR knows the code, knows the text, but it doesn't know from which codable concept type to pull from. So for example, in this case, we have a FHIR snippet that's showing the the priority element on the FHIR bundle. In order to map this to Dataverse attribute, that is priority on an encounter entity, we need to choose the type as codable concept and define the FHIR element map as shown here, and then specify the codable concept type as priority. The important thing to note is the MSEMR underscore codable concept entity in Dataverse has an alternate key on code, name, type. When a FHIR resource is sent and it contains a codable concept, we query the codable concept entity using the alternate key, and if it doesn't exist, we go ahead and create it automatically. This concludes our FHIR Sync Agent mappings session. We have covered Sync Agent data flow, FHIR concept, healthcare data model, and tooling needed to define the maps. And we have seen some examples of FHIR and Dataverse mappings. To get additional information, please refer to the docs link provided on this slide. Thank you.